Okay, guys, let's talk a little bit more about how to algebraically find the domain and range. Sometimes we're going to be given just the function notation, and we're going to need to be able to figure out what the domain and range is. All right, and there's only two rules that you need to remember, okay? You will always assume the domain is negative infinity to infinity, unless you have one of the following two conditions. All right, so I'm going to say it one more time and I'm going to try to beat it in your head this week. The domain is going to be negative infinity to infinity unless you have a fraction with an x in the denominator. All right, why the heck would that be important? Well, remember, we can't divide by the number 0. And so we're going to have to exclude values of x that make the denominator 0. This is something you've already done in the very first week of this course. Remember when we had the rational equations, we had restrictions on x, all right? So we're going to have to exclude those numbers again when we have a fraction with x in the denominator. All right, the other rule that you've got to keep in mind is when we have a square root containing x. Why does that matter? Because we're done with complex numbers and we're back into the land of not being able to take the square root of negative numbers. All right, and so we're going to have to keep in mind that whatever's under that radical has to be greater than or equal to 0. Okay, so whatever expression we have under there has to be greater than or equal to 0. And so when we solve the domain, we're going to have to solve this inequality. All right, let's run through a couple of examples. Y equals x plus 4. First question, do you see a fraction with x in the denominator? No. Do you see a square root with x inside of it? No. So since we said no to both of those, this is going to be our domain of negative infinity to infinity. Okay, and as you can see, if we graph this, if you want to use your TI or graphing calculator in your iPhone or whatever, we can see that this is a line. And how do lines extend? Lines extend forever. All right, and so our domain and our range is always negative infinity to infinity here. Okay. All right, what about this one? Well, here we see a square root with x under the radical. So we need to solve the inequality. We need to take what's inside, the 2x minus 1, and we need to solve greater than or equal to 0. Okay, you guys, this is one of those easy inequalities, right? How do we solve this? Well, add 1 to both sides, divide both sides by 2, and we get x greater than or equal to 1/2. This is our domain. All right, but we want to put this in our interval notation, and so the domain would be bracket 1/2 to infinity. Why a bracket? Because it's greater than or equal to 1/2. All right, again, I can plug in 1/2. If I plug in 1/2 into my function, then I'm going to get 0, or the square root of 0, which is just 0. All right, what about the range? All right, the range we've actually already answered, guys. Okay, and I'm going to grab my pen for a second. All right, remember what we said. We said, hey, this thing right here has to be greater than or equal to 0. All right, but this thing right here is what y equals. And so it's the same thing as saying y has to be greater than or equal to 0. It's where we started when we were trying to figure out the domain. And so again, our range is simply y greater than or equal to 0 or 0 to infinity. Okay, and we can graph this in our TI, and you're more than welcome to use the graph to try to figure out what the domain is. Notice our domain starts here at 1/2. I'm going to try to write a 1/2 here with this pen. All right, and so we go 1/2 to infinity. That's our domain. And what about our range? And I'm going to grab a different color. All right, our range starts here at 0 and goes all the way up. We don't see it go all the way up, but eventually this square root function is going to continue to grow. All right, what about this one? Y equals 5 divided by x minus 1. Again, this is a special case because we have a fraction with x in the denominator. What value for x is going to make that denominator 0? Well, x minus 1 can't equal 0 or x can't equal 1. This is one of those where many of you just look at that denominator and say, hey, x can't equal 1. All right, x cannot equal 1. We need to write this in interval form, excluding the number 1. All right, the best way to think about that is to write negative infinity to infinity, but chopping the number line at 1, excluding 1. So I have negative infinity to 1, parentheses on the 1, union 1 to infinity. All right, and this is the same thing, guys. Well, here, let me go ahead and just talk to you about the range, and then we'll come back to the graph. Since the numerator can never equal 0, all right, we have a 5 in the numerator. The range is y not equal to 0, okay? And so where I excluded 1 in the domain, I have to exclude 0 in the range. All right, and now let's take a look at the graph and see how we can see that. Okay, so we know that the x-axis is our domain, all right? But we have, what we'll learn is an asymptote right here at 2. Our graph can never touch this line right here. We're going to get infinitely close on both sides, but never touch it. I said 2, I mean 1. Dadgummit. Yes, x cannot equal 1. This is a 1, not a 2. All right, let's try again, Angie. Let's try maybe talking about the range. See, I got to keep you guys awake. Make sure you're listening to me. All right, let's talk about the range. All right, the range is the set of all y values. And so the y-axis here, all right, can I attain every single one of those y-axis values? All right, let's look at the graph, all right, over here on the right. I'm following my graph, and I'm going to get infinitely close to the x-axis, but I'm never going to touch it. Same thing over here on the left. I'm getting infinitely close to the x-axis, but I'm never going to touch it. All right, in other words, my function can never touch the x-axis. Well, the x-axis is y equals 0. Okay, in other words, y cannot equal 0.